So good morning everyone. So I'm going to present about my research entitled the AVO analysis of detecting submarine gas hybrid in Lower Fanglio Basin, southwestern Taiwan. And my name is Willa and I'm from National Central University, Taiwan. So to distinguish this presentation, I would like to divide it into several parts. The first one is about the introduction, the theory about the AVO, the data processing sequence, the AVO processing, and furthermore, discussions and conclusion will be presented. So the main goal of my research is to identify the BSR or the bottom simulating reflector for the existence of the gas hybrid and free gas through to the MCS data. And through the specific data processing and the AVO processing, I would like to identify the AVO anomaly. And through this research, I'm going to determine the type of rock, the fluid content, the porosity density, as well as the seismic velocity. What is the AVO? The AVO stands for the amplitude versus offset, or the amplitude variation with offset, which is a variation in seismic reflection amplitude, which changes in distance between shot point and receiver, to determine the differences in lithology and fluid contact or fluid content in rock above and below the reflector. Basically, when the seismic propagate in the subsurface, the amplitude will decrease with offset or the incidence angle. It is because due to the geometrical spreading, the attenuation or other factors. But in this case, in the AVO studies, we are going to analyze that the amplitude will increase with increasing the offset due to the Poisson's ratio changes. And the AVO, it is also have another name as the AVO or the amplitude of variation with angle. And what are the gas hybrids? As we know that the gas hybrids is one of the new resource for the natural gas, and it is one of the potential future energy source for the coming century. The gas hybrid is the gas trapped encaged by water molecules under high pressures and low temperature condition. And the gas hybrid have the gas hybrid stability zone, which is the zone that contains the gas hybrids. And this is my study area, which is located in the southwestern Taiwan. It is the Fanglio Basin, southwestern Taiwan, and study area is located is indicated with the red rectangle, and the color coding represent the BSR depth. And this is my survey line area, which is the MCS 3710 data, and this is the corresponding acquisition parameters. For AVO studies, we also use the Archimedes approximation for the AVO processing. So the Archimedes equation is one of the linearized approximation to the Zuppe's equation, and it is the equation of the Archimedes equation. And Shui rearrange the Archimedes equation into this equation, and finally we got the Wiggins version of Archimedes as the RBB equal to A plus B sin squared theta plus C sin squared theta times squared theta, which is RBB means the reflection coefficient, the A means the intercept time, and it is a function of the VP and density, and the B means the gradient, and it is the biggest effect for the amplitude changes with offset, and it is as a function of PP, Vs, and the density. And C means curvature, and it is the function of P with velocity. And the second approximation, I use the Fatty approximation. The Fatty rearranges the Archimedes equation, and from this equation we can get the impedance, the acoustic impedance for the P and S wave. And it is very important to analyze the AVO processing. And this is my processing sequence. So I divided into two parts, which is the data processing flow and the AVO analysis. I started from the geometry holding, the spherical difference correction, the amplitude balancing, and the CD sorting. For the AVO studies or the AVO processing, it is very important to preserve the amplitude for the AVO studies. And then I perform the bandpass filtering, the velocity analysis, the velocity refinement also, as well as the semblance analysis, and then I got the CDP gather. When I got the CDP gather, I can use it as input for the AVO analysis. And then I perform the super gather and go gather, the AVO analysis, the AVO tribute analysis, and also the cross-plotting. Then we can obtain or we can interpret the seismic data. And this is one of the typical example for the semblance analysis. So I also applied the AGC, or the automatic gain control, before the velocity analysis in order to identify and begin velocity values of the reflector. So from this figure, we can see that this is the seafloor and this is the BSR. This is the process data for my survey line data. So the BSR stems from the bottom simulating reflector. So the BSR is subparallel to the topography of the seafloor, and it is characterized by the high amplitude, and also the negative polarity. So from this section, you can see that this is the seabed and this is the corresponding BSR. You can see that the BSR is subparallel to the topography of the seafloor. And in this case, the BSR have depth vary from 0.4 to 0.5 seconds beneath the seafloor. And we don't need to worry about the multiple, because the multiple will appear 2 seconds below the seafloor. And this is the super gather of the data. So the super gather can be used to improve the signal to noise ratio. The blue line here, the blue line here represent the target area, which is the BSR, and this is the corresponding curve, which is the relationship between the reflected signal amplitude and which change the offset. From this curve, we can see that the amplitude increase with the offset. And this is the theory about the general AVO classification. So as basically, as we know that we have 4 classes for the AVO classification, which is the class 1. It is characterized by the positive amplitude and the decrease with the offset. And the second class, it is characterized by the small amplitude and it may increase or decrease with the offset. And the class 3, it is characterized by the negative amplitude and it will increase with the offset. And the class 4, the reflection coefficient or the amplitude decreases in magnitude with offset. And for the gas hybrid studies, which is the AVO studies, we tend to have the class 3 AVO classification for the gas hybrid response in this area. And this is the AVO gradient analysis with the angle gather data. So we can see that this is the reflection of the BSR, and this is the amplitude which changes with the incidence angle. We can obtain the class 3 AVO response, which is the negative amplitude, and it will be increasing negative with increasing the incidence angle or the offset. And then I would like to discuss about the attributes analysis through anti-LHS approximation. So most popular attribute analysis for the AVO analysis is that the intercept and the gradient value. The intercept value means the P wave zero offset reflection coefficient, and it indicates the variation of the P wave impedance. So from this results, we can see that the blue line represents the BSR or the target zone, and we have the negative value, and it means that the impedance above the BSR is larger than below the BSR. And the second figure, which is the gradient, it is representing the P wave reflection coefficient variation with the offset. And we also got the negative value, and it means that the BSR amplitude increases with the incidence angle. And the third attributes analysis is about the Poisson's ratio changes. So from this figure, we can see that the value of the Poisson ratio is also negative, and it means that the Poisson's ratio is decreasing from above BSR to below the BSR, and it is the derived attributes for Fati approximation. So we can see that this is the P with impedance. We got the negative value, so it means that the impedance above the BSR is larger than below the BSR, and this is the S with impedance. And this is the cross plotting. So we can see that if the layer contains about the fluid content, we will get the data in the background trend around here. And from this figure, we can have the anomaly, which is beyond the background trend, and there is the AVO anomaly, and it is classified as the class 3 AVO classification. So we can conclude that the AVO analysis is very important. It can be used to analyze the gas hydrate or the presence of the gas hydrate, and the BSR were found which vary in depth from 0.4 to 0.5 seconds within the seafloor. And the AVO anomaly has been classified as class 3 AVO anomaly, and the negative value of A attribute, B attributes, and also the negative value of the Poisson ratio can be used as indicator for the presence of the gas hydrate. And also the cross plot is very important for the AVO studies.